Hello everybody. So now we will be solving the next question in the series, which is copy list with random pointers. So let us start with the question. So the question says a linked list is given such that each node contains an additional random pointer which could point to any node in the list or null. Return a deep copy of the list. The linked list is represented. Okay, the linked list is represented in the input output as a list of n nodes. Return a deep. So we need to create a deep copy. So there are so I think there are two concepts which we need to know in order to solve this. So what is deep copy and what is shallow copy? So deep copy is like whenever you are replicating the instances itself, then it makes a deep copy. So suppose you have an object and you want suppose a pointer is pointing to that particular object. Now if you create a deep copy of that pointer, that means it will create another instance of the same object and it will start pointing to it, right? And if you want a shallow copy of that particular object, then you will just copy the pointer and you will also start pointing to the same instance of the object. So you will start pointing to the same instance, but there will be different pointers. So over here we need to create new nodes, right? That is the concept involved. And okay, so I think we are good to go from solution side. So okay, so I think there are some. Okay, so basically we need to return a deep copy such that there is a random pointer which is pointing. So first of all, well, so the first thing first is let us say that we need to create a new. So first of all, so let us say the start is pointing towards the head. So basically, what I will do is I will create the same loads in line. So basically, if suppose this is a linked list 3 to 4 to 1, then what I will do, I will first of all replicate the nodes to itself. I will do it like this. I will do this. So let us first complete this step. So after this step, we can assign the random pointers. So basically, currently st is pointing to this 3. So what I need to do is I need to create a point. So basically yes. So st does not while st is of next is not equal to null, what I can do is st is so I need to create a new node. So new pointer. So next node nxt. So this will be nothing but a new node with a value of st. So I have created another node, right? So I think this is the way we can create a new node. We will check out if it is round. Then what we can do is let's create also, but I need to learn, so I will try this. If this does not work, then we have another method as well. So basically, what is next? So if this is a pointer, then it's next. Also point to the st is next, right? So I think the condition over here should be st because we also want to copy the last node, right? While st is not equal to null. So yeah, this thing is done. So yes, once yeah, so we have created this 3 and this 3 is pointing to this 4. So now st should point, st is next should point to next. And now st should be equal to st is next. So now st is pointing to our 3. Now st is pointing to 4. So now what will happen is it will point to 4. So now next time it will create another 4, and then this 4 will point to 1, this 4 will point to this 4, and then we will point to 1, and then we will point to 1. So 1 is not null, so yeah, then st is null. So yeah, so basically with this step what we have done is we have made this list, linked list. Now once we have made that linked list, now we need to assign the random pointers as well, right? So basically random pointers, so how we will take care of the random pointers. So again, say st is nothing but starting at the head. So we can say while st is not equal to null, so the random pointer of st, so st is next is our node, right? So st is next is our node, new node, and now its random pointer, its its random pointer, right? Its random pointer should point where? So it should point to st's random pointer, right? And now st should equal to st of next, right? So once it will become one, then this random will be equal to this random, then st will be equal to st's of next. Yeah, I think this will work. This will work fine. Now what we want now next, what we want is we want to remove this. So basically, let's say now st is pointing to heads next. So this is the first node on in our table. So this is pointing to this 3. This is the first node in our table, right? So now what we want, that its next pointer should not point to 4, that is the of original version. It should point to the 4 of the new version, right? So while st is not equal to null, what we will do is st's next is equal to st's next. So let me check. So basically once so this 3 will say that my next is this 4, this 4 will say that my next is this 1, right? And then st should be equal to st's next, right? So this 4 will say that this is my, so I am pointing to 1. So now what will 1 say? So st of next, if it is null, stop. Why? Because when we will come at this 1, then we will say that since its next is null, we do not need to operate over here, right? Now but head is still pointing to next, right? So basically this is done and we can return st from here. So this is a kind of deep copy that we have created. So yeah, this line has some errors. I think this is the node, not a pointer. Okay, so this is working. Let's see what is the error coming. While st is next, member access within null pointer of type node. So what if null st is null? No, this is not possible. st is not null. What is this error? While let us say we do not. Next pointer of the node with label 7 from the original list was modified. Okay, so we need to return. So I think there was some error. List is next. I don't think so that this should not any problem. Why I don't know why there is any problem over here. But yeah, what they are saying is true. What we can do is that our head pointer next should also not be changed. So let's say we have another pointer start which is currently pointing to st. Right? So we will return this start. Right? So whenever make it point to head and this step st is next is equal to this value. Right? So in this way we have original list is again made what it was before. Now st is pointing to start. Now again the original list is made what it was before. Now okay, so let me check. So over here we are changing the random pointers of our newly made nodes, right? Yeah. And then st is again pointing to, so start is while st is next is not equal to null, so st is pointing to head, right? So head st of next is equal to st of next, because this 3 should point to 4, right? So I made this 3 point to 4. But before changing this, Let me check. What we are doing is we are creating new nodes and we are saying that their next is equal to, so basically st is currently 3, so we are saying that my next will be equal to st of next. So we made a new 3, right, and we made the value also same, and then st of next we said that okay, st next is next. So now we went to 4 and then we went to 1, and we went to 1, we made another one. Yeah, now I said that st is equal to head, right? So when st I said is equal to head, and while st is not equal to null, now I will change the random pointers. So st is next, the random pointers is nothing but equal to st is random pointer. This is also true. Now st is equal to st is next. Then from these three we will come to 4, and from this 4, because we know that it is of always of even length. So from 0 we will go to 2 and then we will go to 4. Right? Yeah. The next thing is, so yeah, this is, and st is now pointing to start. So while st is next is not equal to null, you need to check if head is null. So let us say we bring this example down. So let us say that currently we are pointing at this particular thing. So my next should be that 4, right? Okay, once we have changed this, then we do not need to go it twice. We can only go it once. Okay. In the similar way, once we have changed this, we do not need to go it twice. We can only go it once. Okay, so for head I need to think. Why? Because so this 3, so st of next. So basically this 3 should point to this 4. Just a second. What we changed is, first of all we should change for the head, I guess. So once the head are changed, now come to the start. So for this, change for this. Now this three is pointing to this four. This four is pointing to this one. St is next should be st is next. So yeah, we changed this. So what we now want, while st is not equal to null, should be the condition in this case. So this is done, I guess, and then st we are pointing it to the start. So this is pointing over here. Now this its next should be equal to st of next. So this next is now pointing to original one. Just a second. So we had this duplicate 3, right? We had, now currently it was pointing to original 3. Now we wanted to point it to original 4. So we said its next is pointing to duplicate 3, its next is pointing to original 4. Yeah. So we are done with this. Now now we are at the duplicate 3. Now we want to point at duplicate 4. But my next is not pointing to the duplicate 4. My next is pointing to the original 4, and its next is pointing to the original 1. So this is wrong. So now what I should do instead, is my I should point to, so okay, so there is no one. Okay, so I guess they have arranged it in such a way that either I will modify the original linked list, so I cannot modify the original linked list. So let us keep two variables, and let us say start original, and let us say, okay, let us say that this is pointing to, let us try to do both of these things. st is equal to head start, and origin is at the head, right? So while st is not equal to null, okay, yeah, we can do this. Now I'm trying to combine both these steps into a single step because I have taken two variables. So org is pointing to this 3 and st is pointing to this 3. So first of all, if I can point org next, org's next should point to xt's next, right? And this st is next should point to org is next. Let me check. So what I am doing is I am saying original is at the head, right? So originals next should point to st is currently at the head's next. So it should point to st is next. So org is next is pointing to this core. Org is next is pointing to this core. But st is next. Okay, so the last pointer might get modified. So if I am at the last pointer, org is next should be equal to the just a second. Here org's next was pointing to this code, then st's next pointed to org's next, the next is next pointed to this code, then org became this code, st became this code. In a similar way, org became this one, st became this one. So st's next is null. So we stopped, but it should be like st is not equal to null. Because in that particular case the last pointer will we will not be able to change the last pointer, right? Yeah, so now when we are at the last pointer, then org is next is null and st is next if it is not null. If st is next is null, then you just go to that st is next, right? Just let me check again. So when we are both at 1 and 1, then st is next is equal to null. So we will stop it, and when we will stop this, just one thing we need to do is to make this as null. So let us run again. Org is next would be equal to st is next. Now org is pointing to this 4. Org is next is pointing to this 4. So now org is next should be st is next. Okay. Random pointer are not getting properly set. Okay, so let me check random pointer. So what will happen is, yeah, st is next random is equal to st is random. Oh shit, it should point to why? Because it is now with the previous code it would be pointing to the original list, right? So st is next random. So like random for these three should be this four, but st's random pointer is pointing to this four. So it should like if st is random, because if it is pointing to null pointer, then null does not have any next, right? So let it be the null. We don't care in the case when it is null. There are different approaches to this question, but I think this approach is fairly good. It beats most of the solutions. Yeah, thank you, and we shall see you in the next video.